Our next example is looking at a two-tailed test. So in this case, there are going to be two critical regions. We're going to find two critical values. So we're told that a random variable x has binomial distribution where the number of trials n is 40 and we've got our parameter p, which we're testing. A single observation is used to test our null hypothesis that value of p is equal to 0.25, or our alternate hypothesis that p doesn't equal 0.25. So the reason why this is a two-tailed test is that we could have either p is less than 0.25 or p is greater than 0.25. So we're going to have the two different tails of that test. We need to find a critical region where the probability is greater than 0.25 and a critical region where the probability is less than 0.25. So we are going to be using for part A a 2% level of significance to find a critical region. And it says the probability in each tail should be as close to 0.01 as possible. So, if we look at then the lower tail, we want to find a value of x such that the probability that x is less than or equal to that value is closest as possible to 0.01. So it needs to be less than 0.02, less than our significance level, and as close as possible to 0.01. So if we look at our binomial distribution table, I'm on the section where n equals 40. We're looking for p is equal to 0.25. So if we look down our list, if we go down, we can see we've got probability that x is less than or equal to 3, that's 0.0047. And the probability that x is less than or equal to 4, that's 0.0160. Now 0.01 lies between both of these values, and both of these probabilities are less than 0.02, our significance level. If we go to probability that x is less than or equal to 5, we've got a value of 0.0433, which is greater than 0.02. So it's going to be either of these values. So if we look at the probability then, we had x is less than or equal to 4. That's equal to 0.0160. And the probability that x was less than or equal to 3, that was 0.0047. So the reason why I've picked out these two probabilities is that they are both less than 0.02. We want the value that is closest to 0.01, and I know that 0.01 lies between both of these values, so now I just need to inspect these values, which value is closest to 0.01, and it's this one here. So the probability that x less than 3 is closest to 0.01, so 3 is the critical value for the lower tail. We're now going to look at finding the critical value for our upper tail. Now this is when we want the probability that x is greater than or equal to a value of x. We want that to be less than 0.02. So that upper tail is when we're looking at greater than or equal to. Now remember, the probability that x is greater than or equal to little x is equal to 1 subtract the probability that x is less than or equal to little x subtract 1. So we're going to be looking at the end of our list of our in our binomial distribution tables and finding those larger values that when we subtract it from 1, we're going to get a value less than 0.02, and we're going to pick a few values and then look at them, see which one's closer to 0.01 as the question has asked us to. So looking at the list then, I found the probability that x is greater than or equal to 19, that's equal to 1 subtract the probability that x is less than or equal to 18, which is equal to 1 subtract 0.9983, which is 0.0017. Now this is less than 0.02. However, I wanted to then look at the probability that x is greater than or equal to 18, which is 1 minus the probability that x is less than or equal to 17, because this value here had a value of 0.9884. So both of these probabilities are going to be less than 0.02, but I just wanted to see which one would be closer to 0.01. So this is equal to 0.0116. Now, if I then inspect these two values here, this one is closer to 0.01. However, I couldn't see that very clearly until I did the calculation of 1 subtracting that number. So that's why I picked 2 to trial. This one is closer to 0.01. So we've got that 18 is the critical value for the upper tail. So we now need to write down our critical region. So the critical regions are, for the lower tail, we had 3 as our critical value. So every value from 0 to 3, that's going to give us that probability that's less than 0.02, sorry. So we've got 0 is less than or equal to x, which is less than or equal to 3. And then our upper tail was 18. So from 18 up to 40, which is the number of trials, the probability that x is greater than or equal to those values between 18 and 40 is going to be less than 0.02 as well. So we've got 18 less than or equal to x, less than or equal to 40. For part B of the question, similar to the previous one, we're asked to find the actual significance level. So the actual significance level, in the previous example, we just wrote down the probability that x was less than or equal to our critical value. For this example, we're going to add the 2 probabilities together that we found with our critical value. So we're going to add the probability that x is less than or equal to 3 to the probability that x is greater than or equal to 18, which is 0.0047 plus 0.0116, which is 0.0163, or 1.63%.